Yes, a question like this reminds us of something in calculus. Calculus has two types. One is differentiation, and the second one is integration. But today we are going to look at one aspect of differentiation, and this is called composite function or chain rule. Yes, when you have multiplication, two brackets multiplying each other, you have what we call chain rule or composite function, which is given as y, u, and v. So what we need to do here is simply to differentiate this expression with respect to x. And we do that by, first of all, taking note of this, which is the y dx. Okay, we're going to differentiate everything about y with respect to x. And how do we do that? Very simple, we're going to keep u. Once we keep u, we differentiate v, alright, with respect to x. Good. And then next, we're using plus because our question has to do with products. So in index 6 we use products, and you convert products to plus. Product simply means multiplication. So multiplication goes with plus in indexes, and the same thing applies here. So the next thing we're going to keep is we keep v, and then differentiate u with respect to x. Very simple. So once we do this, we have started well. The next thing is we identify our u and then identify our v. So we can now say let u be the first bracket, which is 3x minus 2. Then v is x squared plus 3. So we have identified the expression for u and the expression for v respectively. So the next thing we're going to do, we now define this u with respect to x, and then differentiate u with respect to x, and then differentiate v with respect to x, after which we couple them into the original equation given, or formula given, which is this. That's the next thing we're going to do, but we're going to take time to illustrate this. So let's go. Let's differentiate u with respect to x. It becomes du dx. So we have 3x minus 2. When you differentiate a constant term, it vanishes. When you differentiate this, it becomes 3x, 1 minus 1, and this gives us 1 minus 1 is 3x raised to the power 0, and du dx is equal to this x raised to the power 0 is 1 times 3 gives us 3. So we have this for du with respect to x. Then the next step is to differentiate v with respect to x. And we go this way, dv over dx is equal to differentiation that affects constant term vanishes it. And we have only x, alright? And that becomes 2x, then raised to the power 2 minus 1. And this will give us 2x. We cannot say 2 raised to the power minus 1 because the 1 here is hidden, alright? So the next thing here is that we have dv over dx is equal to 2x. Okay, so we now have the derivatives of u and v respectively. What to do next is to couple these derivatives into the original expression, which is this. And once we do that, we are done solving. Okay, so let's do that quickly. We have dy, alright, over dx is equals to keeping v, rather keeping u, differentiating v with respect to x, and then we keep v differentiating u with respect to x. And if that is the case, we now have dy dx becomes something very clear. In place of u, we keep 3x minus 2. Bracket 3x, alright, minus And then in place of dv dx, what do we have as dv dx? We just have a 2x. So what happens here is just 2x, alright, plus. Okay, so we'll move on again. For v, we keep v. And where is our v? V is s squared plus 3. This is s squared, not something else. This is x squared. X squared. So for v, we keep x squared, right, plus 3. Leave it in brackets. And then what about du dx? Our du dx is just 3. Okay? And we do that the same way. Alright, so we have this. The next thing we're going to do is just to marry them in a very stable way so that they become a single expression. And that is done this way. dy dx is equal to, for this becomes 2 times 3x. 2x times 3x becomes 6x squared. This times this becomes 6x squared. And then this times this again, we have minus 4x. Minus 4x. We are done with this. We put our plus sign, big plus sign in it. And the next thing is we use 3. 3 times x squared, we give 3x squared. 3x squared, good. And then 3 times this is going to be plus 9. Good, okay. So with that, we are making progress. We are making progress. So the next thing we are going to do is to collect like terms and then see what remains. We don't have dy over dx is equal to 6x squared, 6x squared. We go with 3x squared because they're common. So plus 3x squared, alright. And then what next? Minus 4x. We don't have any 4x again, so we return that minus 4x. Minus 4x plus 9. Alright. So finally, our final result is dy all over dx is equal to 6x. So we sum this becomes 9. 9x squared. We have 9x squared minus 4x. Minus 4x and then plus 9. Good. So that becomes our final result. That's our final answer. Okay, but if there is any of the steps that you think is not clear, of course you can comment that in the comment box. So that is how to solve chain rule in differentiation concepts.